Hello friends, welcome to my channel. In this video, I am going to discuss about a chapter electrostatic potential and capacitance introduction. Okay, so here we are going to study about electrostatic potential and capacitance. Previously we studied one chapter, that is electric field, electric charges and field. Okay, so this second chapter is a continuation of the first chapter. In the first chapter we studied about the properties of electric field. Now we will study about electrostatic potential in the first and next electric capacitance. Okay, so what is electrostatic potential? Before that we are going to see about a topic, that is gravitational potential energy, that we are already studied in the 11th standard work energy power chapter. There we are studied about a type of potential energy. In that, one type of potential energy is gravitational potential energy, and the same topic we are studied in the gravitation chapter also. Okay, so first I will discuss about that, about gravitational potential energy. What is gravitational potential energy? Gravitational potential energy means what? It is the energy possessed by a body due to its position. Due to its position. It is energy possessed by a body due to its position. Okay, so how a body will get a gravitational potential energy due to its position, we will see. Okay, so I am consider a surface. This is the surface of the earth. Okay, this is the surface of the earth. There is a body of mass m, the body of mass m. Okay, so there is another state is here. How much? This is h distant from the surface. This I am consider, this is the surface of the earth. This is h distant from the surface of the earth. Clear? So here is a mass object. If this object is shifted to here, it will get an energy, that is a potential energy. How much is that? If this object is shifted to here, it will get some energy, that is gravitational potential energy. How much is that value? We already know, that is mgh. How this body got that energy? Because here, what is the force acting on this body? Here there is a downward gravitational attraction, that is mg is acting on it. Okay, so if I need to lift this object, what I have to do? I have to supply minimum this much force in the opposite direction. So I am applying an external force. In which direction? This direction, in the opposite direction. So this is the external force direction. So I will apply external force, or if we need to shift this, we will apply an external force. That external force is in the opposite direction of this. So we have applied an external force and we shifted this body to here. Okay, so we shifted this body to here. Okay, so what is the work done? Work done, the formula is, what is the work done formula? Work done formula is force into displacement. I am consider the force is to be constant everywhere. The gravitational force is constant everywhere. So force into displacement. Okay, so F dot S, Fs cos theta. Clear? If I am consider the external force, what happen? F into displacement. What is the displacement from here to here? That is h into cos 0 degree. Okay, so otherwise I can write how much? I can write it as F external into h. Okay, cos 0 value 1. If I will be considered as a gravitational force here, so what will be happen? This gravitational force is in the opposite direction of the external force. So we'll take it as Fg into h. What is the Fg value? Fg value is this mg. So minus mgh. This is the work done by the gravitational force by shifting an object from here to here. Okay, so here an external agency is doing a work against this gravitational attraction force. So this work done is stored as a potential energy. Okay, this is the potential energy at this point. So more clearly, I will be take another situation, that is, I will consider this is the surface of the earth. Okay, this is the surface of the earth. I will consider as a point here. There is a point here. This is how much distant from the surface? This is h1 height, and there is another slope, it is there, that is how much distant from here? That is h2 distant from. Okay, so here I have an object. Okay, that is how much its mass? I am considered m. Okay, so if I will shift this object, how much is the, what are the forces are acting? Downward mg, that is the gravitational force. If I need to shift this object to here, what I have to do? There is a downward gravitational force is there. I have to supply a external force that is in the opposite direction of the gravitational force of attraction. So I will supply an external force. So what is the work done? Work done is equal to F external dot yes, that is displacement. Okay, F external dot displacement. Okay, F external and displacement are in the, so that means I am doing the external forces in the direction, displacement also in the same direction. So F external into displacement. What is the displacement? Displacement means final position vector minus initial position. What is the final position vector? That is h2. I am considering earth surface is the reference point. Okay, so h2 minus h1. Okay, so the gravitational force is in the opposite direction, so we will consider as minus Fg into h2 minus h1. What is the gravitational force here? That is mg. So minus mg into h2 minus h1. Okay, so this is the work done. What is the work done here? You can see that minus I will be take it as common. That is mg h2 minus h1. Mg h2 minus mg h1. mgh2 minus h1. So this work done, so here I can say that I am to be doing a work done to shift an object from 1 to 2. How much is this? This is the thing. What is this? This is the potential energy. Minus mgh is the potential energy of this point. This minus is common for this. Okay, so common for this. So here what I can get? Here I can write it as potential energy of the which position? This position, that is u2 minus, this is the, if this minus is common, this is to be the potential energy of this point. So I can write it as work done to move an object from one point to another point is equal to change in potential energy. Okay, so here we are doing a work done against the gravitational force. So this change in potential energy is what? Change in gravitational potential energy. Okay, so if we are doing a work done against any force, there is a potential energy is to be stored. Okay, so here work done to shift an object from one point to another point is the change in potential energy. What is that change in potential energy? U2 minus U1. U2 is the normal symbol we are using for the potential energy. Okay. So U2 is the final position potential energy minus initial position photon. U2 minus U1. If an object is shift from 1.1 to 2, potential energy is the final position minus potential energy of the initial position. This same concept we are going to apply in the electrostatic. Okay. So electrostatic potential energy we are going to see here. Okay. Electrostatic potential energy. In the electrostatic potential energy, what we are going to see in the electrostatic potential energy? In the electrostatic potential energy, here we are assuming it as a charge. What is the charge? I am here assuming it as a plus Q charge. Okay, this is a plus Q charge. From this, there is a point P is there. Okay, there is a point R is there. Okay, this is a point P, and there is another charge Q. Here there is a charge is there. Okay, so this charge Q, clear? This charge Q is to be placed initially at R. This is the setup we will be doing. Okay, so from this plus capital Q will produce what? Electric field away from it. Away from it, what it will produce? This will produce an electric field. In this electric field, what is the charge? The Q charge, this small Q charge is to be placed. Clear? So this is experience a repulsive force. Okay. So what I will going to do means, I will bring this charge from R to P. Okay. What I am going to do? I will bring this charge from R to P. What I have to do? Is there any work I have to do? I have to do a work because here there is a repulsion is there. While I am coming, I am bringing closer and closer to this plus Q charge. The repulsion of this capital Q will be increases. So I have to supply more work done. So I have to supply a work done. Clear? Okay. So that how much is that work done? So I have to supply a work done. Work done to move a charge from R to P. Okay. So how much is that work done? Here the force is, the electrostatic force is varying from place to place. Where is the external force? I will do an external force is in this direction. This is the external force. What about the electrostatic force? This is the electrostatic force is in this direction. So this is my external force. If coming closer and closer and closer, this electrostatic force is increases because the electrostatic formula is Q into E. E value is how much? What is the E value? Fe is equal to the force experienced on a charged particle in a electric field. Okay, that is QE. What is this capital E? This capital E is the electric field produced by this. Okay, so electric field produced by this formula is 1 by 4 pi epsilon 0 Q by R, if R is the distance. If the R distance will be decreases coming closer and closer and closer, so what will be happen? This E value will be increases, Fe will be increases. So if we need to bring again closer and closer, we have to supply. So this is a case of work done by variable force. So work done by variable force formula is integration of F external dot dx. Okay, dx is the small displacement. Here the displacement and external force are to be in the same direction. So I can write like this. Instead of dx, I am to be using a symbol dr. Okay, so you can use dx also. There is no problem for that. So I will use F external into dr. Okay, dr is the small displacement. Okay, this is the F external. If this external is how much? If this external is, I will be changed to in the electric field. What this electrostatic force is in the opposite direction of external force. So I will do a negative sign here. Then what we will get? F into electric field. F E into dr, integration. From where to where we are shifting? R to P. Integration to R to P. R to P. Okay. So work done to move a charge from R to P is equal to how much? Integration of R to P Fe dr. Okay, this is the work done. So we already studied here what we are doing here. The electric field is acting in this direction, electric force is acting in this direction. So here the external force is acting in the opposite direction of the electric field. So this is also a case. Anywhere we are doing a work against a field, there is a potential energy stored. So here also the same case. So we studied in the previous, work done to move a charge from one point to another point is equal to change in potential energy. So here also work done to move a charge from R to P, work done to move a charge from R to P is equal to work done R to P is equal to how much? Change in potential energy. What is that change in potential energy? Potential energy at the final position. What is the final position? UP minus potential energy at the initial position. Initially it is at R. Here we are doing a work against the electrostatic field. Okay, here we are doing a work against the electrostatic field. So what about this change in potential energy? This is a electrostatic change in potential energy, or work done to move a charge from one point to another point in an electric field is the difference between final position electrostatic potential energy minus initial position electrostatic potential energy. This we can write. Work done to move a charge in an electrostatic field is the change in potential energy of that two points. Okay, this is about the introduction of the first part. Okay, again there is something is there. Next topic is electrostatic potential energy at a point, that we will be discussing the next part. Okay,
thank you for watching the video. Please subscribe my channel. If you like this video, please put like